Okay, in this video I'm going to continue with the CG9 homework starting with number 6. And in this one you're asked to find the perimeter of quadrilateral zoid and also the area. So what we're going to do is use the distance formula to find each side of the quadrilateral, and then use the add them all together, right? So for this problem, let's just start with, we're going to have ZO, we're going to have OI, we're going to have ID, and ZD. Now you could graph it, you don't have to, and if you do, it's going to be a very irregular shape. But before I do, I'm actually just going to use, in my opinion, the distance formula is the easiest on this one. So with ZO, first it's x2 minus x1. So let's do that. Let's do -8 minus -6 squared. And then we're going to have y2 minus y1. So 3 minus 5 squared. And that's going to be equal to, let's see, -8 minus a -6, that becomes positive. And so that's -2 squared plus -2 squared. That is equal to square root of 8. 4 plus 4. So square root 8. And that's going to be approximately 2.63 units. And then we do the same thing with OI. So OI is the square root of, let's see, -3 minus a -8, right? Or, no, actually, pardon me, x2 minus x1. So 14 minus a -8 squared plus -3 minus 3 squared. That is equal to 22 squared plus a -6 squared, which is equal to 484 plus 36, which equals the square root of 520. That's approximately equal to 22.8 units. And finally, ID. ID is the square root of -1 minus 14 squared, 5 minus a -3 squared, and you're going to have -15 squared plus 8 squared. When you do the math, you will get 225 plus 64, or 289, and that will equal 17. Okay, finally, ZD. ZD is equal to, well, that one's actually 5 minus 5. You can see the y value is the same, right? So if you were to graph that, you could just count, and that would be 5. ZD is 5. Okay, because the y value is the same. Great. So the perimeter will equal, approximately equal, 2.83 plus 22.8 plus 17 plus 5, which approximately 47.63 units. Okay. Now this is definitely an irregular shape. And so finding the area is going to involve dividing the shape up into triangles and then finding the area of those triangles. And when you do that, you're going to get 48. A is equal to 48. Okay, that concludes number 6. We'll say units squared. And then number 7, determine whether triangle DEF has these vertices as scalene, isosceles, or equilateral. Well, let's see. Let's go ahead and plot this here. So and again, you don't actually have to plot this. I find it helpful to do that, but you don't have to. The distance formula doesn't require you to do that. So what I'm going to do is on the x, I'm going to go up by 5s. So 5, 10, 15, 20, 25, 30, 35, 40. And I'll just do the same scale on the y-axis. Okay, so 39 minus 12 is about right here. 6 minus 6 is about here. And 2418, right about there. There we go. So that's our plot. This one with the numbers being so big, I'm going to go ahead and do the distance formula. So we need to find the length of each side. So DE, EF, DF. Okay, so with DE, you have X1, Y1, X2, Y2. So what's X2 minus X1? 39 minus 6, which is 33. And what is Y2 minus Y1? It's minus 12 minus a negative 6. Right, so for this one, if you have Y2 minus Y1, minus 12 minus a negative 6, which is the same thing as minus 12 plus 6. It's going to be minus 6. And when you square those numbers, you'll get 1,125. Because negative 6 squared is going to be a positive 36. So you have positive 36 plus 1,089. Okay. EF is going to be the square root of, and this time it's changed, right? So now this is x1, y1, x2, y2. So 24 minus 39 is going to be negative 15 squared, and 18 minus a negative 12 is going to be 30 squared. Be the square root of 1,125. So it looks like it's either isosceles or equilateral. Let's see what the next one is. So for this one, DF, with DF, I'm going to have x1, y1, x2, y2. So x2 minus x1 is going to be 6 minus 24. I'll just write it out this time. That's going to be minus 6 minus 18. So 6, that's going to be negative 18 squared plus negative 24 squared. Negative and negative is a positive. So you're going to get the square root of 900, which is going to equal 30. Okay, so this triangle, since it has 2 congruent sides but not 3, it is isosceles. Okay, good. All right, that concludes the CG9 homework.